Welcome back to the workshop. We want to continue taking a look at section 4.2, which is paths and circuits. Yep, excellent. And we want to look at the Euler circuit algorithm. So let's take a look at our notes. Now, we're not going to go through all the details of the Euler circuit algorithm, but what I want to do is I want to briefly describe what exactly we're going to do. So in the Euler circuit algorithm, we're trying to find an Euler circuit like we did in our previous example. And to do this, what we're going to do essentially is, if I were to get rid of the path or the circuit that we did use, what we're going to do is we're going to try to start by creating a small circuit that once I get back to D here, for example, I've used up all of the edges at D. So I can't go anywhere else once I get back. But was this an Euler circuit? Did it cover all of the edges? No, it didn't. So what I want to do is I want to take this this circuit or this cycle that I do have. It's still not a cycle either. Cycles don't repeat vertices or edges. So this is a circuit, but it's not an Euler circuit. It doesn't have everything. But I can expand this so that way it does, right? I can take this as my first try. So first try is in green. And then what I do is I just pick a vertex that still has some edges available on it. So I cannot pick D, but all of the other vertices in this case still have something available. So I'll just pick B arbitrarily. And what I'm going to do is I'm going to take my take the path that I had in green, which was let's see here, I did D, C, E, D, D, C, E, D, and then I went up to B, A, and back to D. And what I'm doing is I'm taking this B right here, this B, and I'm going to expand it. And I'm going to expand it, so right here, instead of going to A, I'm going to say, hey, you know what? Let's go over to E, up to A, down to C, and over to back to B. So instead of going off to A, I'm going to add this extra red loop. So in my second try, I'm actually going to take everything that was from my first try, D, C, E, D, and then the B that I had, right? I'm taking this, thing and I'm replacing it with, right? I'm going from, I still, of course, go to B, but then I'm going over to E, up to A, down to C, and back to B. So I added this little bit extra in to the loop that, or to the circuit that I already had. The circuit I had, right, this wasn't everything. So in my second try, I'm adding in these extra edges to make my circuit a little bit bigger. And in this case, it does include everything. So once I'm back, so I added in my red edges there, and then I'm still going to A, and then I'm still going back down to D, right? So I'm still have my green path or my green circuit, but I've added to it this little bit of a red circuit to fill in. I picked up the remaining edges. So in my first try, I didn't get all the edges. It's okay. We can fix that. We can fix that by expanding the path or by expanding the circuit. So that way we eventually include all edges. And maybe we didn't get it on the second try and we have to try again at another vertex. Okay, so it might take 2, 3, 4, 5, or a dozen tries. Usually just a couple tries is sufficient. So, and that's what the Euler circuit algorithm tells us to do. What we do is it has us initiate. It says, all right, let's consider the edge set. So when I consider the edge set, I'm trying to color all of these edges so that way I know I've traveled them. So we set E to be the set of all edges. Excellent, we're looking at all the edges. And then pick the starting point. Pick some vertex to start at. I chose D to start at for this example, okay? And from here, what we do, right, we get started. Excellent. And then what we do is we expand the path until necessary. This is our first try. But when we get done, when we got done with our first try, that set is, there were some edges that we hadn't used yet. So here what we do is as we create our first try, as we create our first circuit, we're actually removing the edges from our list of edges. So that way we know which ones we've traveled. So as we remove them, we've traveled them. So once there are no longer any edges to travel on, right, this set of edges should be empty and we should have traveled all of the edges. So in our first try, we didn't travel all of the edges. And so we say, hey, look, the set of edges is still not empty. We gotta travel these ones still. So let's go ahead and give it a second try. And we expand along some other vertex, okay? And we plug that in, right? That in this last step here, where we replace our vertex with the new path that we were adding in, or that new circuit. So that's what this algorithm is trying to say here. We pick a starting point, we give it a first try, right? The thing is we're going to exhaust that starting vertex. We want to continue on until we no longer, when we come back to it, we can no longer leave it. So that was our first try here. We went D, C, E, D. I can still travel away from D, so I go up to B, A, back to D, and then I can't go anywhere. I'm done. I'm stuck. I can't leave the vertex D. However, I did not travel all of the edges, so we have to expand. Okay, that's the idea. And then, of course, in our second try, when we expanded B, we went out and then came back to B, and we couldn't go anywhere else. Once we could no longer travel any further, that's when we're done. And that should occur when we get to B. Now, what's interesting about this that we definitely need to pay attention to is that this only works where the graph has vertices of all even degree. All of the vertices have to have even degree, which we'll find later is the only way that we can actually have an Euler circuit. It's given as a theorem. So in this case, all of the vertices were degree 4. Excellent. So it should work, and it did. If we wanted to, in this next example, we can use the Euler circuit algorithm to find a path. And we'll take a look at how that works out in our next video. So for now, we'll call this good. We talked about the Euler circuit algorithm. We didn't go through all the details, but we kind of gave a description, and we'll actually do this again on our next graph. So I'll see you guys back in the workshop in just a moment.